Okay, morning people. Now we are back with another one. This time is what? 10.12. Same problem, same textbook. So in this case, a strip of steel, 3 millimeters thick and 35 millimeters wide, is bent around a cylindrical drum of 4-meter diameter. Then this D stand for determine the maximum stress set up in the strip and the bending moment which has to be applied to bend the strip. So to this curvature, then we are given that E is equal to this. So basically this one does not really need technical approach, it's just theory. So we're gonna do it. So from there we know that M over I is equal to over this and E over R. This is just theory. So I don't want to skip this question, but I just want to show how to approach it. You can still use the method, but this one is totally different. So let's just draw the structure because you can still follow this. So we can draw a beam and a cross section. So now let's draw a beam. So we are not told this is a beam. So in this question, just imagine a strip, as they say, a strip. I'm gonna draw it into 3D this time. I'm not gonna draw it in simple terms. So we have a strip, then have a cross section of what? 3 millimeters thick, 3 millimeters thick, and 35 millimeters wide. So when you can see, you can tell that this is 35 millimeter, and then this is what? 3 millimeters. So sometimes it's difficult to even complement without an actual structure, right? But wide is always like on the top part. So if you know that wide is here, that means thickness is here, right? Basically wide means, if I have to draw a cross section, wide is always touching the ground. If you can imagine like that, wide is always touching the ground. If I'm touching the ground, this part will touching the ground, that is wide. So this one is 35 millimeter, and then this is 3 millimeters. Unless it was 3 millimeter thick and then 35 millimeter deep, then you know deep is the horizontal vertical part. Okay, this is what we have, right? And then what do these people want to do? They want to bend around the cylinder. So now imagine a cylinder, and then with a radius of what? Diameter of 4 meters, and then they want to get the string around it. So let me just draw a front view of it. So we have a circle, then we have another circle, right? Then we have another. I don't know why I draw two. I was supposed to like end at one, but it's fine. Let's just scrap this one. Let's just do this. We have a round, and then we have this. So this is the diameter of the time, and then this is what? This is 3 millimeters thick. So what is this? The thing that I'm highlighting now, it's kind of, you have a drum and then you rotate around. The strip is rotating around. So if I was to draw like side view, we have something like this. Oh yeah, I was supposed to draw. Excuse my drawing. So yeah. So we have something like this. This is this strip. So in this diameter is 4. This is the drum, and then we have this. So basically this is what we have. This is a structure. In the side view, yeah, front view, even though yeah, this is a front view. So they ask us to determine the maximum stress, and then you can just see we have E, we have R, and then what is the left? And we need this, you see. So the only thing we need to find is Y. Simple. Y is just, you just go to the straight cross-sectional area and then just X, X, Y, Y. This is a simple question, and you should not even making a video about it. So we have something like this. E is equal to E over R times Y. Then it's 200 times 10 exponent 9. Then we have, what is our Y? Our Y is just, remember, this is AP. There's no force here. You just imagine, obviously if you want to bend it, you're going to apply force somewhere here. So obviously the force is coming this, I mean this is indeed AP. Y1, Y2, both of them, they are equal, which is equal to what? 3 over 2 times 10 exponent negative 3. So we have 1,5 exponent 1,5 exponent negative 3. So it's gonna 1.5 times 10 exponent negative 3 over R. What is my R? The diameter. Yeah, it's 4. Yeah, it's 4 millimeters. It's not really 4 millimeters because according to the theory, you need to bend it in the Excel. You see, you need to bend it here. Meaning what? Meaning what? We have to include this length because we are rotating apart. When you go to the theory, you will find that we are rotating apart the neutral axis. So neutral axis have a distance of what? 3 over 2 meters. Then you need to include it in that 4. And remember, it's R, not a diameter. So from here to the center of the neutral is just 2 plus 3 over 2 times 10 exponent 3. So it's 4 over 2 plus 3 over 2 times 10 exponent negative 3. I hope you understand. So we have something like this: 200 exponent 9 times 1,5 exponent negative 3 over 4 over 2 plus exponent negative 3. And then my calculator said error. Don't understand why. Okay, let's start again. 200 exponent 9 1,5 exponent negative 3 divided by 2 plus 1,5 exponent negative 3. So we have something like this: 149,88 times MPa. You see? Then so we have determined the maximum stress, and then and the bending moment. So now we have asked to determine m. So basically this is a simple question. Basically you can still use E over R is equal to m over I. Then we need to find I. Just go to the cross section and you'll be done. I is equal to height, which is what, 3 squared times 35 over 12. This is in millimeters. So we're gonna have something like this. M is equal to E R over I. R over I. 200 times 10 exponent 9 times 3 squared times 35 divided by 12. We have 26,25 millimeter 4. So this is just 1 over 1004 over what is my R again? 2 plus 3, 1.5 exponent negative 3. So it's 2,0015. So the final answer is what? Is there something wrong? 3 squared, this is millimeters, times 35. Oh, cube over 12. That is 78 divided by 1000 exponent 4. So this is not 26 times 200 exponent 9 divided by 2,0015. So we have our m equal to 7,869 Newton meters. So we need to change this. So 3 cube times 35 divided by 12. So this is actually 78,75. So yeah, pay attention. Basically this is it. Nothing straightforward, nothing weird.